introduction together. But because I'm speaking right now, so I have to introduce myself to you. So just first tell me, are there foreigner students in your in the class or not? Because in that case,
Yes,
I
yes,
okay. Because then I cannot switch into Urdu unless some student really has some issue, and there I have to switch in the Urdu language. Right now I'm teaching from my office because I like to teach from my office when there are online classes, even when everything is closed out there. So in that case, it's always good because university's internet is better than those that are available at home. My name is Dr. Humayun Ijaz. I am associate professor of chemistry at chemistry department. I'm teaching here at UET for the last 14 years. I joined UET in 2007 after doing my PhD in chemistry from Germany. I have a master's in analytical chemistry from Punjab University, a master's in inorganic chemistry from Germany, and then I had my PhD in inorganic chemistry from Germany. So I taught my first lecture, I think, to the first chemical engineering back in 2007. So they would be your super duper duper seniors, I guess. Uh, for the last a couple of years, I was given this responsibility to teach this third semester because previously, before like around 4 or 5 years ago, there was a subject that was uh, inorganic and analytical chemistry. But then your department changed that, and then you have two different chemistry subjects. One is this one that you studied in your first semester, that was the physical and analytical chemistry, and then you have this third semester where you study inorganic and organic chemistry. So because I am a specialist of inorganic and analytical chemistry, so my department gave me the responsibility for this inorganic portion. Last year, Dr. Farat joined me for this subject for the organic portion. This year, he was not willing to teach. So there is another teacher, Dr. Mazhar, that will teach you. So this classroom I have shared with him as well. So he will teach you on your respective date. So just first let me confirm with you that do you have these classes like previously according to section A's timetable, or we have to teach like on 2 days? What's the scenario?
sir. We are going to study according to the section 8
Okay, then it's
or
good because
on online classes. Just online classes.
for the online classes, right?
Yes.
Okay. Now, my way of teaching is that I'll provide you all the notes. The note slides are given over there. Even when you have the physical classes, uh, definitely I'll tell you the book readings from where you can read for your own interest. For example, in my case, I got some readings from there are two books I prepared these lectures from. One was the Inorganic Chemistry by West, and there was another book that I consulted that is basically not allowed, but definitely it was an Indian author. So it is a very comprehensive book of inorganic chemistry, that is inorganic selected topics in inorganic chemistry by Tooley. So he's a professor of chemistry in India. So that book is very comprehensive. Any student who has any interest in inorganic chemistry, that book comprises of every different aspects that is quite capable to cater the needs of bachelor as well as master students. So most of my things are from these two books. But for examination point of view, you do not need to go to the libraries for the searching. Definitely for the assignments, when I'll give you the assignments, you definitely have to go to the library or you need to search from the internet. But for the examination purpose, these notes are more than sufficient. Okay, if you have understood everything, then these notes are more than sufficient. All the notes I am telling again are available in this class section. If you have any problem, I can even send to the CRs before the lecture as well. So you will get those notes. One more thing that I always like to do for the online classes is, not today, I'll start the recording when I'll start the teaching. There will be recording of every lecture. So there will be a gallery of recordings. in the recording settings, and you can play and you can rejuvenate your knowledge whenever you want. So you will not be having any issue. Even sometimes some students are not available, or there are some internet issues or electrical issues, because we are living in Pakistan. So you can go and you can just search the respective lecture and you can just play it. So there, this is something that is not compulsory from the university, but I always feel it better that students should get access to the, because these are online classes, and I can understand this is not as easy as the physical contact with the teacher. And I always like the physical classes more because the time is similar. I mean, I have to get ready, I have to come to my office. I am teaching here on the laptop, so it's better if I come to your department. I'll teach to the whole class. So, on lighter note, before going to study, I don't know you. Most of you would not know me. As I said, that I started 14 years ago here, and then we have another subject that we are having specialization in our department, that is food science and food science and technology as well. So our department is comprised of two departments: chemistry department and food science and technology department. So I had a great interest in nutrition and especially sports nutrition as well. I'm a certified fitness trainer, certified nutritionist as well. So if sometimes students have any issue with some kind of fitness related things, then you are welcome to my office for that as well. Also, I am an elected senator of the university. University has two main bodies that basically run the universities. One is the Senate and one is the syndicate. So these are two prestigious bodies, and I am happy to be the elected member of the university senate as well. I'm university's proctor as well. So for the disciplinary issues and everything, all these things. Anyways, that was a brief introduction from my side. So I don't know how many students are there yet. I have to go and see here. So we have around 60 students. I think there are ample amount of students, so I can start. So I'll start with the recording of the lecture as well. So let me see. Every time they change the interface a bit. Okay, I got this because it's been 6 months. The last time I started, I had this online class before. Okay, so we are going to start the recording of this lecture. Okay, so first let me introduce about the subject itself. As these are two different things together, inorganic and organic chemistry, I'm responsible for the inorganic portion. And this inorganic portion constitutes of various different aspects. So I'll name some aspects to you. I'll go through the syllabus that I have for this thing. So, talking about the inorganic portion, we'll go and we'll review the product table, molecular orbital theory, chemistry of solution and transition metals, coordination compounds and their properties, crystalline state of metals and lattice structure, and industrial inorganic chemistry, and some theories of inorganic chemistry here as well. So, although it is written in this way, we'll start with the uh, basic thing regarding the coordination chemistry, because then we'll be able to understand more about these things. Now, when we talk about inorganic chemistry, it is basically something that comprises most of the universe. Organic chemistry is a very little portion that is on our planet. Maybe 99% of the universe itself constitutes of inorganic compounds. Mainly, you have the you know the hydrogen and all these things. So we have inorganic compounds everywhere around us. Our own body constitutes according to a great extent about and around the inorganic substances. So whenever we talk about inorganic thing, it comprises of a class of the chemical compounds that is namely or normally without the carbon, hydrogen, oxygen, something like that, and then you do not have the covalent bonding, pure covalent bonding there. So talking about that, we have a huge portion of product table that basically talks about inorganic chemistry. And then within this portion, we have the D block elements, which are a unique type of substances where you have a number of possibilities that can arise from the inorganic side or from the coordinate covalent side, and they constitute, and then you have there uh, there is a linkage between the inorganic and organic thing, where we say that these D block elements form the metal complexes. So they can be classified as inorganic compounds, but at the same time they have bonding many times with the ligands, which are basically the organic functional groups. So this, like, it's a marriage of the two things. You have the metal and you have the ligands, and this type of chemistry is known as coordination chemistry. So today we'll start with the coordination chemistry, but before that we need to understand the d orbitals and the situation of the d block elements, how they basically work. So what is basically coordination chemistry? As I said, we have d block elements, and they have a bonding which is basically a coordinate covalent bond. And maybe you know what is coordinate covalent bond. It is a bond between the two entities where the electron pair is being furnished by one. So you have a Lewis acid and a Lewis base, just like the formation of ammonium ion, where you have ammonia, which is electron rich, and you have the hydrogen ion, which is electron deficient. So the ion is formed when ammonia donates its electron pair and forms a coordinate covalent bond. And so you have many other examples that I am hope you have already studied in your previous studies. So, what is coordination chemistry? It is a branch of chemistry that deals with the formation of metal complexes, coordination compounds, coordination complexes. So, these are all the names of the same thing. Sometimes we say them metal complexes, sometimes we say them coordination compounds, sometimes we say them coordination complexes, or simple complexes, metal complexes. So it deals with the formation of coordinate covalent bond between metal atom or ion and ligands. So there is a very unique thing. Some, maybe you would have an idea that metal is always in the form of ion when it reacts to form a coordinate complex. It is not true. Some, most of the time it is a metal ion, but sometimes it is even in the neutral elemental state as well. And there are complexes where the metal is in zero oxidation state, the ligand has no charge, and yet they form very stable complexes. For example, tetracarbonyl nickel. This is one example where nickel is in zero oxidation state, mean it is in elemental form. Carbonyl is or carbon monoxide is a very stable compound itself. But why on earth they are coming together and forming a complex? This is a very interesting situation. Means a very stable metal is reacting with a very stable gas to form a very stable complex or compound. So what urges them to make a complex? Now this is one question to you, general question, and you will face this question many times whenever you will go for vivas or interview. Why a compound is formed? Can anybody answer me? Why a compound is formed? एक कंपाउंड बनता ही क्यों है? Why a compound is formed?
स्टेबल होने के लिए।
ऑक्टेट रूल या डुप्लेट रूल को फॉलो करने के लिए।
Yes, exactly. Basically, these are the explanations for that. But the real thing, the student has already said before, to get itself stable, thermodynamically, kinetically stable. So that means compounds are even stable than their parental species. So that is why they are formed. So very good, you both answered correctly. That is the reason why a complex is formed, because this metal wants to form, for example, in case of nickel 0, it is D8 configuration, and then it wants to complete a octet maybe, and therefore it would go and make a complex. And that even inside the metal you have the metallic bonding. So metallic bonding would not be there if there was no any urge for these metal to be stabilized. So metal acts as a Lewis acid or electron pair acceptor, where the ligand acts as a Lewis base or electron pair donor. So you have this situation where metal and the ligand, they come together and they form. So this was basically simple M. There is just R is an additional thing. You can just skip it. So metal and ligand together add together and they form an adduct. So metal complexes are basically an adduct of two different. These are not substitution reactions. These are the adducts where two entities come together and add together and they form a complex. So metal complexes are also the adducts. So together they form coordinate covalent bond, and a new compound complex or adduct basically is formed. This is one thing. Historically, as you might have thought that metal are the cations and ligands would be the anions. Previously, it was the view of the chemist as well. That is why valence bond theory and crystal field theory, they think the metal ions to be the cations and ligands to be the anions. So it was very convenient for them to think that okay, the reason for their attraction is because metal is a cation and ligand is an anion. But later on, molecular orbital theory proved it to be wrong. So the point that is known as point charge model, which is obsolete, means it is no more there. But we have to study all these things to know how the science basically advanced in its traveling toward the modern concept. So point charge model considers the metal as a positive point charge or cation, and ligand as a negative point charge or the anion. It considers their interaction as ionic, but the following reaction later refuted the model. So I just discussed about this reaction where nickel was in its zero oxidation state. It was not a cation, and carbon monoxide was not an anion. It is a stable compound. So together they reacted and they formed this complex which changed the course of the coordination chemistry and is known as tetracarbonyl nickel. Sixth point to be discussed is various theories are of importance in the field of coordination chemistry, like Blomstrand-Jorgensen theory, Werner theory, valence bond theory, crystal field theory, and molecular orbital theory. We will go and we'll study all these things. So today is just an introduction. So I'm just going to make your friendship with these coordination compounds. We'll go and we'll study all these theories in detail when in the next lectures. And I really wish there would be physical lectures so that it would be more convenient for you to understand the things. But before going to this whole thing and whole mess of coordination chemistry or the theories that are related to that, or even the crystalline chemistry, we need to understand the properties of D block elements. As I said, D block elements are a very unique part of product table, because in the other S and P block elements, you can predict the filling by various principles that okay, this is 1s2, 2s2, so and so on. When it comes to the D block elements, the filling of the orbitals is not basically compatible with the other aspects that we see for the S and P block elements, and I'm sure that you are quite acquainted to this thing. Elements where the differentiating electrons enters, it is enters again, D is the typo, The n minus 1 d orbitals are known as d block elements. So we know that only thing that we know is that okay, uh, we have three main series of d block elements, and then you have the outermost orbital. We do not use the word shells now. Okay, so this is one thing. Shell is an obsolete thing. Okay, they are there, but they do not have a real physical characteristic. The main thing today that we discuss are the orbitals. Maybe you would have studied them as subshells, but today we say orbitals are the reality. They are there, and they are the one that basically interact with each other. So the differentiating electron mean every electron that is coming next is coming in the d orbital. So the outermost orbital is the d orbital. So this is a very simple definition that you might have studied, that the differentiating electron enters the n minus 1 d orbital, and they are known as d block elements. Sometimes they are also referred to as transition metal elements too. So sometimes you say them transition metal elements because they are in transition of filling of their d orbital. D orbital is a very big orbital. It contains 10 electrons. So you have 10 elements where you are basically seeing the d orbital as their outermost orbital, or more specifically outer transition elements. They are also known as outer transition. So there are many names for it: d block elements, transition metal elements, outer transition elements, while F block elements are known as inner transition elements. A number of properties of D block elements are based on the D orbitals. So far, if you have any question, then you can ask. कोई सवाल किसी के जहन में है? So if you have any question, you can ask so far. So I think these are the things that you have already studied. This is what I assume so far. So far, it's okay and clear to you. If you have having any problem with this,
No, sir, clear.
okay. So there you have 5d orbitals, and you see two are the axial ones and three are the non-axial ones. You have the axial orbital as d, this one dx square minus y square. You have the axial one which is d z square orbital, and you have the non-axial one which is dxyz, dyz, and dxz orbital. So you have 5d orbital, and every orbital has the capability of accommodating 2 electrons. That is why you have 5d orbitals, namely you can accommodate 10 electrons in them. Now I have one question. There is an element that is zinc. Its d orbital is completely filled. But can you say it to be a transition metal element or not? Can we say zinc to be a D block, sorry, a transition metal element or not?
I think a compound, sir.
No, I am asking. We have zinc is an element where you have all the electrons of in the d orbital completely filled. It's a d10 configuration. Can we, because transition metal element has a definition that their d orbital are in transition of filling. Can we say zinc to be a transition metal element or not?
Sir, they are non-typical
Exactly.
transition
Not,
element.
they are non-typical because by definition they are not transition metal. This is not a transition metal element. Either it is zinc, down there is cadmium, and below it is mercury. So these elements are non-typical transition metal elements. They are d block elements because still their outermost orbital is d orbital, but they are not in transition of filling, so they are not typical d block elements exactly. So properties, they have metallic character, and when we say metallic character, you might get an idea about the physical metallic character, but there is also a chemical metallic character as well. Okay, for some students, with the permission of the outsider students or international students, I'll speak sometimes in Urdu as well. But before that, I'll definitely explain the things in English as well. So I know many students would not be so good in understanding the English language. So it's always good to give one or two lines in Urdu as well. So as I said, when
Yes.
we talk, yes, sorry,
It's okay, sir.
thank you. So metallic character. Whenever when somebody say it's just like a metal, what image comes out in our mind generally is a very solid thing having a shine or a luster inside it. So always we correlate the metallic character with the visuals of our own mind. So this is a physical metallic character. But then there is a chemical metallic character as well. But before going to the chemical metallic character, let's discuss the physical metallic character. And fortunately, D block elements, most of them show us these two types of characters. Definitely, there are some exceptions, and there are some exceptions like mercury or cadmium or zinc, but there are the reasons for that, and we'll discuss the reasons there as well. For example, D block elements have high melting and boiling points, except with some exceptions. They are hard, malleable, ductile, good conductors of heat and electricity, and they show shine, luster, with few exceptions. Now we know why this and how this trend basically works over there. If we see these, specifically these three main transition series, these one are synthetic, so we do not count them. This fourth transition series is something which is synthetic, so we do not count it to be a transition metal element. Generally, when we talk about when we say three series of transition metal elements, these are those which are naturally present over there. And then you have these. Acha, one thing is that there is only one element in this D block element main series which is synthetically prepared. This technetium is not available in the universe so far as the scientists know to be present. Technetium was a gap inside the product table, which scientists later on synthetically prepared. Otherwise, all these elements of the first three transition series, they are naturally available. And you see most of them are solid in nature. But this last group over there, as I said, zinc, cadmium, and then mercury. This is a very interesting aspect over there because zinc is not as solid as other transition metal elements. They are very, if you touch that, that is a very soft metal, but still it is solid. Cadmium is even softer, and mercury is in the liquid state. The reason for that is that these elements, they have completely filled d orbitals, and they do not show a stronger metallic bonding between them. All other elements of d block elements, they are not having a completely filled octet or completely filled d orbital in that case. So that is a reason. For example, in case of nickel, it is d8, as I already said. Maybe in case of manganese, it is d5. So d5 is having half filled electrons, and half electrons are not filled over there. So what it would like to have within the metal, because the neighbor is also manganese, it cannot snatch the electron from the other because their electronegativities would be the same. What they would do, they would instead they would make friendships with each other, and this is a friendship that we say is a metallic bonding. So some, it would say, okay, I'll get your outermost electron for some time, I'll complete my octet, and the next time you will get all these electrons and you will fill your octet. So this is how, it's a kind of a covalent character. and there you have the metallic bonding. But in case of zinc, it is already an established. They उनका पेट भरा हुआ है. They are like D10. They do not need further electrons from the next neighboring zinc element. Okay, so that is the reason they do not make very good metallic bonding. As a result, when you move down the group, the size of the atom increases. When the size of atom increases, their nuclei would be further apart from each other, and this would again decrease the metallic bond character. Whichever is left over there, जितना थोड़ा बहुत भी character है, that would be diluted, that would be decreased. As a result, from coming zinc to cadmium and from cadmium to mercury, the metallic character is so much decreased that the mercury exists in the liquid formation over there. So that is the reason why we see mercury as a liquid, one of the few elements in the deep block elements that are in the liquefied state. Is it clear to you, students?
Yes, sir.
If you have any question, you can even raise your hands or you can even interrupt between. I would not mind for that.
सर एक
सर
और एलिमेंट है जो रूम टेम्परेचर पे मतलब लिक्विड में कन्वर्ट हो जाता है, सॉलिड टू लिक्विड में। सर उसकी भी मतलब प्रॉपर्टीज सिमिलर हैं या डिफरेंट
Which element?
क्या
Which element is that? D, is it a D block element?
सर एलिमेंट का नाम नहीं यार, मैं देखकर बताऊंगा।
Okay. Okay, there was another student's question.
सर यहाँ पे जो अभी हम ये वीडियो की बात कर रहे हैं, तो जो मेटालिक रिएक्टर या मेटालिक बॉन्डिंग की बात कर रहे हैं, ये हम इलेक्ट्रॉन की थ्योरी की बात कर रहे हैं या दूसरी या मेटालिक बॉन्ड की?
आपकी आवाज ठीक नहीं आ रही थी.
ओके, सॉरी सर।
हम्म.
सर यहाँ पे जो मेटालिक बॉन्ड्स की अभी हम डिस्कस कर रहे थे, ये इलेक्ट्रॉन की थ्योरी है या मेटालिक बॉन्ड्स की बैंड थ्योरी है?
No, this is basically the theory of electrons. We're not talking about the band theory at the moment. This is something else.
ओके सर, थैंक यू।
Okay, so this is what is written according to the electronic viewpoint. Cases of zinc, cadmium, and mercury are different because they have completely filled d orbitals and therefore show not a strong metallic bonding in between their atoms. As we move down the group from zinc to cadmium to mercury, the atomic size increases and further decreases the metallic bonding, resulting in the liquefaction of mercury. So this is already something that we have discussed from this figure of the d block elements. Then you have another type of character, which is the metallic character. And this is the chemical metallic character. So physical metallic character is something which is related to their physical aspects like hardness and all these things. But a when we say it is chemically metallic, means it is easy to ionize. That means, for example, if you want to, if you have nickel in zero oxidation state and you convert it into nickel 2 plus, so it is not a very difficult thing. They require, their basically ionization potentials are not too high. You do not need a lot of energy to ionize them. So that is why D block elements, they are intermediate between the S and P block elements. Okay, so D block elements जो हैं ना, उनको इतनी एनर्जी चाहिए हाई एस पी ब्लॉक एलिमेंट्स की तरह कि वो आयनाइज हों, और ना उनको इतनी कम एनर्जी चाहिए एस ब्लॉक एलिमेंट्स की तरह कि वो रेडिली आयनाइज हो जाएं. So that is the reason S block elements, they most of them, they are available in their ionized states in nature. But D block elements is something which are always in variable situations. आपको metals भी मिलेंगे, आपको ions भी मिलेंगे इसके. ठीक है? So in interestingly, this is a unique aspect. Chemically, the ionization potentials are lower than P block elements and higher than the S block elements. But as they do easily ionize, they show good chemical metallic character. As we see, as a result of this ionization, deep lock elements do exist in various positive oxidation state, and there is a story related to it. You see these ores that are of iron and different metals around you. The reason of these ores are the oxides of these metal. Iron oxides are very abundant around you in the earth crust. The reason for that is that initially, when there was no any plants, or when there was a very when there was no any living organism over there, I am talking about the scientific aspect. So this theory, or this is not a theory, basically this is a real story that science supports. When first of all the anaerobic organisms were produced, it was okay, they were not consuming oxygen, and sorry, they were not expiring oxygen outside. But once the aerobic organisms like us were produced, most of them were in the sea, like these plants, and they were exhaling oxygen out of them, and this caused a disbalance in the ecosystem, because a lot of oxygen was coming over there. And maybe you know it or not, oxygen is not a very good gas. It is flammable, it is a poisonous, not for us, but generally at that time it was a poisonous gas. So what happened later on, when these plants produced oxygen, a lot of oxygen was released in the atmosphere, and the atmosphere wanted to balance the things. So what happened? The oxygen was dumped in the form of ores. This oxygen was reacted with the iron and with other metals at that time. And because of this property of these elements, these d block elements, they were able to form, for example, iron 2 plus, iron 3 plus. We'll discuss this later on as well. You see a number of oxidation states, and this is because of these different oxidation states, they were able to deposit all these ores inside the earth crust. But once you know what, once these oxygen was quite deposited and still there was abundant of oxygen, then the nature, or maybe Allah Ta'ala decided to form organisms which were able to consume that oxygen. And so from the anaerobic to aerobic respiratory process was then started. Those organisms were generated which were able to consume that oxygen, and those organisms were able to live in that environment. So that was something that, this is geobiochemistry, but we are not going to discuss all that. Just to give you a glimpse that how these different ores were established and how these d block elements were able to form these ores, and this is because of their chemical metallic character. Okay, so chemical metallic characteristics mean they are able to exist in various oxidation states, and then you have various oxidation states of these metals, and the reason is that they are not so easy to ionize as s block elements, and not difficult to ionize as p block element. They are intermediate, and they are very good metal in the chemical metallic form in that case. Okay, so that was for today's week one. I think that is enough for today. I don't want to load you a lot with a lot of inorganic chemistry today. If you have any question, then you can ask for now.
सर वो मेटल जो था सीजियम था.
Cesium is in the S block element. It is not a D block element.
Okay.
So we're talking about D block elements. In case of S block element, definitely they have a different chemical arrangement and atmosphere. So that is why this is something else. In the case of cesium, the S block element, they are readily, ionizable. They, most of them, they exist in the ionized form. So they have different physical and chemical properties than those of the D block elements. So you have any question, then you can ask. And I think I can just
Yes,
stop the recording. Yes, please.
Can you come go back to the periodic table, please?
Which one?
The periodic table you was opening on.
Okay, product table. Yes, over
Yeah,
here.
here in the right, you said that there is something increase and another thing decrease. What was it?
I said that when you move down the group, so there are definitely when we see a product table, there are hundreds of different properties that can change when you move along the group or down the group or up the group. But at the moment, we were only discussing their physical metallic character. And as you move down the group, specifically for the zinc, cadmium, and mercury, their metallic character is decreased because the metallic bonding is diluted, the metallic bonding becomes weaker. They are all, these three of them, they have completely filled d orbitals, and they do not like to have a strong bonding with the next d orbital. With zinc, there is some metallic bonding because the size of the zinc atoms are big enough, and the nuclei of the zinc atoms, they would be close enough. But as you move down in the cadmium, it is even softer than zinc because they are far away from each other because of their size. And mercury is even bigger. It's just like, fat students sitting on one bench. Even the bench is the same, but when the three fat students are sitting, their heads would be far away from each other. Same is the case with mercury. The mercury would be more far from each other, and that is the reason the metallic bonding will be decreased and it will exist in a liquid state.
Okay, sir. Thank you.
Okay. And one more aspect I was telling you, that technetium is only one transition metal element in the main, because we say these three series to be the main, the first series, second series, and third series. It's only transition metal element that exists in the that does not exist in the nature. The scientists have not found it anywhere in the universe. They have created it synthetically. So the technetium was never seen before, and scientists were able to create this element because there was this gap in the product table. Okay, is it clear to you, students?
Yes, sir.
Yes, sir.
Okay,
Thank
so
you.
let me finish the recording over there. Recording will be available. Normally, it is available after maybe a couple of hours because MS Teams sometimes has to process it, and then it will be uploaded directly in the gallery. So if you have any difficulty approaching to the notes or to the recording, then you can ask me, but I think there will be no any issue for that. So with that, I would ask the CRs to please mark the attendance of their respective classes. It is sometimes difficult for me to download this report because of some software issues. So I would request the CRs to download, or GRs to write or to manage their attendances of their respective classes. Okay, and with the hope to see you next week inside the classroom. Yes,
सर
Gigi.
सर डाउन सर डाउन द ग्रुप हमारी जो शील्डिंग इफेक्ट है वो इंक्रीज हो रही होती है
देखिए
तो
मैं
जो
बहुत
मेटेलिक करैक्टर
हाँ हाँ
सर तो जो मेटेलिक करैक्टर है यानी केमिकल मेटेलिक करैक्टर वो तो इंक्रीज होना चाहिए ना
shielding effect
हाँ
is something else. Shielding effect is the effect of outermost electrons, right? So when you have the shielding effect, for example, you have two atoms together and their shielding effect is increasing, mean they are the inner shell electrons are repelling or repelling the outer shell electron. What would happen? The incoming or the next element, they would be far away from each other. So shielding, either you come from the atomic size point of view or from the shielding effect point of view, they would repel each other, and so the size would be increased. And as the size would be increased, the nuclei of the two adjacent elements would be far away from each other, so the metallic character would be decreased in any case.
ओके सर थैंक यू
Welcome. So, yes, please.
सर वो ओर्स वाली बात एक दफा रिपीट कर दें।
वो तो मैंने एक स्टोरी आपको वैसे तो रियल स्टोरी है, बट मैंने ओर्स वाली बात जो आपको बताई थी वो ये थी कि नेचर ने जब, क्योंकि पहले एनारोबिक रेस्पिरेटरी सिस्टम से ऑर्गेनिजम्स प्रोड्यूस हुए थे उन्होंने ऑक्सीजन को देना शुरू किया जब, तो एनवायरनमेंट में ऑक्सीजन बहुत ज़्यादा हो गई। जब इन्वायरमेंट में ऑक्सीजन बहुत ज़्यादा हुई तो नेचर, क्योंकि नेचर डज नॉट लाइक to disturb the system, and equilibrium must be established. So nature tried to consume that oxygen, and with this increased oxygen in the atmosphere, it was deposited in the form of ores. तो आयरन के ओर्स बने जो हमें आज चट्टानें नजर आती हैं, सिलिकेट्स हैं, आयरन के ओर्स हैं और वो इसलिए बन पाए क्योंकि आयरन वगैरह मुख्तलिफ ऑक्सीडेशन स्टेट में एग्जिस्ट कर रहे थे। तो ये मैंने बात बताई थी। और एंड में ये मैंने बताया था कि जब बहुत ज़्यादा ऑक्सीजन फिर भी पैदा हो रही थी और नेचर इक्विलिब्रियम एस्टैब्लिश नहीं कर पा रही थी, फिर नेचर ने हमारे जैसे ऑर्गेनिजम्स एवेल्यूएट एवॉल्व किए जो ऑक्सीजन को कंज्यूम कर सकते थे। सो देन द ऑर्गेनिज्म स्टार्टेड लिविंग इन दैट डेंजरस एटमॉस्फेयर। Oxygen is a very strange gas. It is, although we cannot live without oxygen for more than 3 minutes, oxygen is basically the cause of the death as well. Because with this oxygen comes the free radical. That is why आपने सुना होगा antioxidant लेना चाहिए and all that. So oxygen deteriorates our internal organs as well. So oxygen is necessary evil. This is a very interesting sentence that what I read in one book. Without oxygen, we cannot live for 3 minutes, and without that, and with that, we cannot live for like 70, 80, or 90 years. Okay? So oxygen is a necessary evil. So with the
सर
hope that we'll meet, G.
सर मेटालिक कैरेक्टर और मेटालिक बॉन्डिंग में फर्क है?
Metallic character, तो metallic देखिए, there are two types of metallic character. Metallic bonding is a physical aspect. Metallic character is the appearance of that. What how we it appears to us. It appears to us because of its physical metallic character. हमें लगता है कि उसमें physical metallic characters हैं. And the second is its chemical metallic character. Chemical उसकी habit क्या है? Does it ionizes very easily? Then we say yes, it ionizes easily. That is why it is a chemical metallic character. And when we talk about metallic bonding, it is a totally different aspect. This is how the because वो भी कॉपर है, वो भी कॉपर है इन विद इन द सेम एरिया। वो कैसे इलेक्ट्रॉन्स एक दूसरे, जाहिर है वो छीन तो सकता नहीं है बिकॉज दे इलेक्ट्रोनेगेटिविटी इज द सेम। सो व्हाट दे वुड डू, दे वुड मेक अ kind of covalent character within them, and this covalent character, that is why आपकी अगर मेरे सामने चाबी पड़ी हुई है आयरन की बनी हुई, सो ये चाबी इंटैक्ट क्यों है? बिकॉज ऑफ दिस मेटालिक character that it has or metallic bonding that it has there. So metallic bonding is a theory that says how these atoms are combined together, एंड मेटालिक करेक्टर उसकी एप्लीकेशन है। ठीक है, इज इट क्लियर टू यू?
जी सर। सर
ओके, जी जी।
सर डी ब्लॉक के ज्यादातर मेटल्स ग्रे होते हैं लेकिन गोल्ड का कलर फिर चेंज क्यों है?
Not all of them are gray. You have all these different shades, and it depends upon how the light falls on them, and you have various types of crystal structures over there. For example, iron has generally a body centered cubic structure. ठीक है, so there are various reason. For example, आप एक स्ट्रक्चर को डेवलप करते हैं एंड देन यू pass a light through that, you may see a gray color structure. And if you have another type of arrangement of the same of these atoms, the color would be appear to be different. Okay, so it depends upon the type of crystal structure that structure has. Then you see different ways of reflection of light from that. So that is how you see various colors. Copper is kind of orangish, gold is yellow, mercury is totally, silver color. Silver itself has a silver color. Iron has a gray color. So it all depends on how the atoms of the specific element is packed and how the light reflects out of that. That makes the color appear in our eyes. ठीक है. Okay, I think we are at the
सर एक
end of the
क्वेश्चन.
time. जी जी पूछें.
सर ये
Last
जो
question.
ट्रांजिशन एलिमेंट्स होते हैं, मेटल्स होते हैं, ये मतलब रेडियो एक्टिव तो हो सकते हैं.
Transition metal elements can be radioactive only when you make, isotopes of them. If you synthetically do something with them, and then they will maybe convert into kind of radioactive material. Otherwise, this is not a natural character of them. ये उनके नेचुरल कैरेक्टर में नहीं है जब
सर
तक आप
जैसे
उसको
हमने
ऐसा खुद ना करें.
टेक्नीशियम का पढ़ा कि ये सिंथेसाइज किया गया, बनाया
हाँ
गया,
हाँ
तो ये
एग्जैक्टली.
रेडियो एक्टिव ही होगा ना मोस्टली.
It definitely because whenever you synthesize something, वो इतनी स्टेबल होती तो नेचर उसको पहले बना छोड़ती और वो अपनी स्टेबल फॉर्म में होती. जो सिंथेटिकली बनाई जाती हैं they just decompose in few seconds or sometimes few millisecond, and when they decompose definitely they radiate something out, and so there they can be. So whenever it is natural d block element, I don't see any reason for them to be radioactive. Otherwise, other elements which are synthetically prepared, they might show some radioactive properties. Okay. So hope to see you next week in the class. I wish it would happen. With that thing, thank you very much and Allah Hafiz.